Today it's my pleasure to come back to southeast Turkey and the famous site of Göbekli Tepe and the site surrounding it. In my last talk, I went into a few details about the relationship between Karahan Tepe and Göbekli Tepe, and I also talked about the solstice angle at Karahan Tepe. Today I'm going to go more into the details about the landscape geometry between Karahan Tepe and Harbetsuvan Tepesi and also Harran, which is in the plain at the center of the whole of the Göbekli Tepe area. In the initial slide here, I've got a picture of Abraham because we'll be seeing that Abraham seems to have played an important role in this area. So let's get in. And the first thing I'd like to talk about then is this grid that I showed going from Göbekli Tepe to Karahan Tepe and Harbetsuvan Tepesi. Now this grid is a 4x7 grid. So I showed how between Karahan Tepe and Göbekli Tepe, there is a 3 north-south by 7 east-west relationship, and that there's an added square which goes down to Harbetsuvan Tepesi. Now, I'd shown in a previous video that Harbetsuvan Tepesi was linked to Göbekli Tepe on a 2x3 ratio, which would be 4x6. What we see here is that Harbetsuvan Tepesi is not exactly in the corner of this grid, which it should be if Harbetsuvan Tepesi was on a 4x6 ratio with Göbekli Tepe, then it would be exactly in the corner, which it isn't. So what's going on? How can this be the case? And what I want to look into is the fact that one of the things about Google Earth, first of all, I'd like to say that between Harbetsuvan Tepesi and Karahan Tepe, there is visibility. One site can be seen from the other. Okay, so that's an important point. And also, Harbetsuvan Tepesi can be seen from Göbekli Tepe. There's visibility right across the valley. Now, I'd like to go into an important point about the angles as traced from Google Earth. Now, Google Earth gives you an angle from the place you're looking from. So if you draw a point in a certain direction, you will get the angle of what you're looking to, which is a very good idea. If you want to get the angle of a sunrise, for example, from where you're standing, then you want the angle from where you're standing. You don't want an average angle over the whole distance. Now, why is this a problem? Is because the Earth is round, and so as your line goes across the planet, it slightly changes its angle because of the Earth's curvature. So the angle, say, from Harbetsuvan Tepesi to Göbekli Tepe will not be the same as the angle seen from Göbekli Tepe to Harbetsuvan Tepesi. It's slightly different. So when I showed the geometry from Harbetsuvan Tepesi to Göbekli Tepe with a 4x6 or 2x3 grid, I was going from Harbetsuvan Tepesi looking towards Göbekli Tepe. And in that case, that is a perfect angle of 33.63 degrees, as can be seen here in the diagram. 33.69 degrees, sorry, is the exact angle to 1/100th of a degree when you look from Harbetsuvan Tepesi towards Göbekli Tepe. Now, when you look from Göbekli Tepe towards Karahan Tepe, here the angle of 23.2 degrees is the exact angle seen in that direction, and that's the exact angle of a 3x7 grid. Okay? But when you put these two grids one over each other, they don't quite fit because of the Earth's curvature. So you can see that the red line of the 4x6 or 2x3 grid is not exactly over the yellow line here, okay? The red line is the 2x3 grid, and the yellow would be 4x6. It's not exactly over it. And what seems to have been done here by the builders is they seem to have taken into account the Earth's curvature using geometry to compensate this difference. This is quite an incredible assertion I'm making here, but it's what seems to come to me from looking at these different angles. So if we look into the corner, this corner square between Karahan Tepe and Harbetsuvan Tepesi, I've divided it into 21 little parts, 21 by 21. So here we can see on a bigger scale, Karahan Tepe to Harbetsuvan Tepesi. And here's the grid of 21 by 21. So I've got 21 north-south and then 20 to Harbetsuvan Tepesi. Now, this is an angle, so it's not exactly 45 degrees, you see. It's not exactly on the corner here, seen on this distance. Now, this is in fact very interesting because the 20, 21, 29 is a Pythagorean triangle, one of the famous triangles with whole numbers on all three sides, okay? And these triangles were very much used, as I've shown in numerous occasions, in ancient mathematics and ancient geometry. And so what seems to have been done here is that there's been a compensation of 1/20th of a unit, of a square, 1/21st part of a unit, to compensate the difference between the angles, okay? So if we look at this, we can see that the angle this time from Göbekli Tepe to Harbetsuvan Tepesi here, if I take this angle on Google Earth, I get a result of 123.48 degrees and not 123.69, which is what I would have got on a 2x3 square. So it's a slightly smaller angle. That gives me a ratio, a tangent of 84 over 127, which can be doubled to 168 over 254. Basically, I have 84 units north-south and 127 units east-west, okay, to get this specific angle in this direction. So if we look at my 4 squares and I divide those 4 squares into 21, that will give me 81 small squares, 84 small squares north-south. Okay, multiplied by 4. Now I have 6 east-west. If I multiply them by 21, I get 126. And then if I add one little square to this, I get 127. And so we see that the angle from Göbekli Tepe to Harbetsuvan, which is 84 over 127, has been calculated by adding an extra square, which is 1/21th or 21st part of the larger square, okay? Which means that in this final square, we have 20 on the base and 21 north-south, which is this Pythagorean triangle. So this is quite an astounding geometrical fact, which you can check up on. It's perfectly precise to 100th of a degree. And I have a lot of trouble thinking that this was done by accident, okay? Taking into consideration the Earth's curvature using this modular geometry like this is a very, very subtle way of doing things. Now, let's have a look now at the relationship with Harran. So here we can see the town of Harran in the center of the plain. So we can see the kind of mountains around, which are arid. And then in between the mountains, we have the plain of Harran, which is watered. There are rivers coming into it here. And so all this is fertile agricultural land, flat, very flat, fertile. So it's a sort of fertile basin. And of course, very handy if you want to get a certain population around here, okay? So Harran was a place where people could come and a population could grow. And it was a big town, okay? And what we see is that if we draw a line between Karahan Tepe and Harbetsuvan Tepesi, we come to the center of the Harran sort of central square. So if we look in at this, first of all, we can see the visibility. Karahan Tepe is here, so it's not visible from Harran, but Harbetsuvan Tepesi is visible. Okay, from Harran up to Harbetsuvan Tepesi, we have visibility there. Okay? So that's an interesting point. And if we come into the center of Harran here, there's a kind of big central plain. And in the center of that, there's a square, where there are the remains of ancient buildings. I'll come into this in a second. What I'd first like to, well, here we can see the tower, for example. This is an observation tower, which was built there, with this very strange doorway into it. And we can see the walls of the square that we could see on the central plain. There are a lot of remains of stones and things. This is all very ruined now. No activity here, but here's another picture of it. So you can see the remains of these walls. There was a monastery here. There used to be, right from the beginning, a Islam university. It is said to have been the first university of Islam, founded around the 11th century. And so here you can see the big plain of Harran and this central square and the observatory, the observatory tower here. Okay. And from this photo, we can see the horizon towards the east, and Harbetsuvan Tepesi is about here. So 28.4 kilometers distance from the square on the hilltop here. Okay, so that's very interesting, clear visibility. There's a slight difference in altitude, but over 28.4 kilometers, it makes very little difference as far as the angle is concerned. So here's this central place, and here's the central square. There's the tower. Okay, that's the square. I discovered that this square had been inclined in a certain way with respect to cardinal directions. In fact, you can see there are 7 squares on either side of this big square, and the inner square has been inclined or turned so that its sides are on the diagonals of those squares, okay? So that's very interesting fact. There's a square like this, and that has been turned, so as to speak, so that it fits into the diagonal of a larger 7-fold square all around it. Okay, so that's with respect to cardinal directions, north, south, east, and west. So the whole thing has been tilted slightly according to an angle of 1/6. So let's come back now to this relationship between Harran and Karahan Tepe. We can see that the line going up to Karahan Tepe down to the center of Harran doesn't quite go through the archaeological site of Harbetsuvan Tepesi. It's just beside it. goes just next to it. And if we look at the terrain here, so here's the site of Harbetsuvan Tepesi. This is a 3D Google Earth image, and we can see the site is on the hilltop here. But the actual perfect geometrical line, as it goes through here, through the grid, it's on a sort of cliff face. Okay, so the site of Harbetsuvan Tepesi seems to have been offset slightly to account for the terrain, the natural slope of the land. But in fact, the angle itself is absolutely perfect. So if we go now to Google Earth, I'll just show this to you on Google Earth. So we can zoom in here on Google Earth to Harran. And I'm going to put a point in here in the center. And now I've got a grid on there which I can take off to start off with. So if I put a point on here, there we go. And now we go up to Harbetsuvan Tepesi. Oh no, we want to go to Karahan Tepe. So let's go right up to Karahan Tepe. Here we're at Karahan Tepe. We can see here that the angle is 43.60 degrees. Again, I've got a big grid there. Perhaps I can take that off so we can see a little better what's going on. Okay. Here's the site of Karahan Tepe. This is exactly the center of Karahan Tepe. And we see that the line coming up has an angle of 43.6 degrees exactly from the center of the square at Harran up to Karahan Tepe. And 43.6 degrees is the exact angle of the Pythagorean triangle. We can have a look at this if you like. If we take 43.6 degrees and I take the tangent of this, it gives me this value. If I multiply that by 21, I get 19.998. Okay, so this shows that 43.6 degrees is the exact angle of 43.6 degrees of this Pythagorean triangle, 2021, and so 29 units on the hypotenuse, so 29 units between Karahan Tepe and the center of the square in Harran. Okay, now, so I'll clear that off. And if we look at the properties of this, we can see that the distance is 35,032 meters. So if I divide that by 29, it gives me a unit of 1,208 meters. Okay, so that's an interesting fact. Okay, so if I put the grid here now, I'm gonna now put the 21 by 29 grid right from Karahan Tepe down to Harran. So we can see here that the center of the square is exactly at the corner here. That's the corner 21. So here we have 21 minus 1 square, 20. And 21 squares up here. Okay. And we can see how Harbetsuvan Tepesi is placed here in respect to that. Now, what I noticed when I placed I noticed as I was doing this that when I placed this grid of 21 by 20 between Karahan Tepe and Harran, I noticed that in fact it perfectly fitted in to the grid of 4 squares by 7 squares, which I had placed between Göbekli Tepe and Karahan Tepe, 3 by 7 and then 4 by 7. I realized that you can see these squares actually fit in perfectly. You can see how the 4 squares are perfectly aligned to the squares above. Now, there was no reason that this should really be the case. I've drawn a grid of 21 by 21 between Karahan Tepe and Harran, and this grid perfectly fits in to this 3 by 7 grid that I've drawn between Göbekli Tepe and Karahan Tepe. So this clearly shows that there's some kind of unity here. You see, it's absolutely perfect. Okay? And so I realized that I could then, of course, draw a grid of the same size over the whole area between Göbekli Tepe, Karahan Tepe and Harran. So I did that, and here it is. And this enabled me to see that this grid, which is 28 squares on the east-west side by 33 squares north-south, links together these different sides. So that's quite an astounding fact, because each square is 1,200 meters long. These are not small squares, you know, and it's absolutely perfectly precise. If I come up to the corner here, we can see we're right in the corner at Göbekli Tepe, right at the site. Okay, here are the different circles at the Göbekli Tepe. So it's just on a massive scale, a really incredible precision. Okay, so that's something quite astounding. So if I come back now to this presentation, we can see how this grid fits in with its different numbers. So as I said, the whole grid is 28 east-west by 33 north-south. So, of course, I had here a 3 by 7 ratio. So that becomes 12 by 28. 3 times 4, 12. 3 times 7, 28. That becomes 12 by 28. I have 20 to 21 ratio here on the Pythagorean triangle, 20, 21, 29. Okay. This leaves 8 squares here, and 33, if I had 21 to 12, 33. So between Göbekli Tepe and Harran, I should have an 8 by 33 ratio. And in fact, that's exactly what I have. If I come back to Google Earth and I draw in these ratios, so Göbekli to Harran here, let's put the large grid on. That's in there. Here's Göbekli to Harran. And if I actually do this ratio, I have an angle of 166.37 degrees from Göbekli Tepe down to Harran, which is the exact inverse tangent of 8 over 33. So this is very, very interesting and very important to see that there was some kind of massive organization positioning these different monuments. This cannot be by chance. I mean, we're talking about a grid using whole numbers and Pythagorean triangles. This cannot be done by chance. And the different sites aligned, Karahan Tepe, Harbetsuvan Tepesi in the center at Harran. Okay, so that's very important. Now, I'd like to talk about Abraham, or Abram, as he was first called. There's an extract in the Hebrew Bible, what we call the Old Testament, in Genesis chapter 11, verse 31. Now, I don't know if this is a coincidence, but 1131 is a very important angle. 11.31 degrees is the angle of a 1 by 5 square, which is, if I have 5 squares side by side and I draw the diagonal, it's 11.31 degrees. Is that just a coincidence? God knows, but that's a rather strange thing. Anyway, in Genesis chapter 11, verse 31, it says, Terah, who is Abraham's father, Terah took Abraham his son and Lot, the son of Haran, his son's son, his other son's son, and Sarah, or Sarai, his daughter-in-law, the wife of Abraham, his son. And they went out together from Ur of the Chaldees into the land of Canaan. And they came as far as Harran and settled there. So here we learn that Abraham, his father, his wife, his brother, a whole load of people actually left the town of Ur and moved up right along the valley, right along the Euphrates Valley. Over a very long distance, they moved up to the town of Harran, which we've been studying. It'd be interesting to look at this relationship here. I have the town of Ur here, so we can go to the town of Ur. And here it is. You've got I'll change slightly the image. That's a bit clearer. So this is the town of Ur, and this is the ziggurat of Ur. And we're at a latitude here of 30.966 degrees, or 962 degrees, okay, which is very important. I'll be coming back to that. And what we can see is that if we go from Ur up to Harran, I don't know if I have that line already drawn. Maybe not. But we can do it. Why not? We can draw a line here from Ur. We're going to be able to... Yes, that's good. Up to Harran. Okay. So that's a distance of 925,000 meters, or in miles, 574 miles, or in nautical miles, it's 500 nautical miles, which is rather surprising. And if we look at this path, if we look at the path that Abraham and his family followed, we can see that they basically went up the river Euphrates. Is near the Euphrates here. This is the Tigris to the north and the Euphrates. And they moved up the Euphrates here. Okay, following the Euphrates. And then they moved north here to Harran. Okay, so that's quite some trip. And there may be a very interesting reason that the Hebrew Bible talks to us about this, okay? And that's what I'm going to look into now. Because if we look at the ziggurat of Ur, the latitude of Ur, as we saw, is 30.9637 degrees. And this is a very specific latitude, because at this latitude, if we have a pillar which is 5 units high, whatever those units may be, 5 meters or 5 feet or 50 feet or whatever, if we have a pillar which is 5 units high, then at equinox at midday, we will get a shadow of exactly 3 units long. This is specific at this particular latitude. According to the latitude you're at, the length of your shadow at equinox at midday varies. But that's the time that you can work out the latitude you're at. And so the tangent of 3/5, the inverse tangent of 3/5 is 30.9637 degrees, which is the exact latitude of the town of Okay? And you can see this in this triangle here. It's the angle of this triangle between the pillar and its shadow. Okay? So the town of was placed at a very specific latitude linked to whole number geometry. So Ur's latitude is geometrical, quite clearly. It's perfect. Okay? Now, if we go to Harran, to the town of Harran, we see here that the latitude of Harran, look at this, 36.8698 degrees. It's here on Google Earth, 36.8698 degrees here. That is the exact angle of the inverse tangent of 3/4, or the angle of a 3-4-5 triangle. So at the latitude at Harran, at midday on equinox, if you have a pillar of 4 meters height, then you'll have a shadow of 3 meters long. Okay? So this is really quite astounding that the Bible tells us that Abraham goes from to Harran, and we discovered that these two spots have really perfect whole number latitude relationships with the position at equinox. Okay? So Harran's latitude is geometrical. So Abraham and his family went from the 3-5 equinox ratio in to the 3-4 equinox ratio in Harran. And to do that, they traveled 500 nautical miles right up the Euphrates Valley. Now, that's really quite astounding, and it must be seen to be some kind of indication given in the Bible of what was, how these different sacred places were being chosen. Harran was made a religiously and politically influential city through its association with the moon god Sin, also known as Nana in So the major god in was the moon god, known as Nana, or also known as Sin in And the ziggurat of on the top of the ziggurat of was a temple dedicated to the god Sin. Okay. His symbol is a crescent. It's called Sakar. You can see the Babylonian cuneiform writing here to express it. Okay, and we see Sin very, very often represented with this horizontal crescent moon. You can see one here on the left, and then here, horizontal crescent moon. Here's another depiction of Sin with this horizontal crescent moon, and I'll come back to this in a further talk. This is a very interesting subject because I've looked into the question of just up to what latitude can you actually see a horizontal crescent moon? What's the most northerly latitude you can see this? And in fact, this representation of a horizontal crescent moon can be traced right back to the megalithic period in Karnak. in France, there are engravings with this symbol. So this is a very important fact, which I'll come back to in a future talk. So the main cult center of Sin was and Sin was recognized as its tutelary deity and divine ruler. Sin was also closely associated with Harran. So we see that this relationship between and Harran is linked to the god Sin also. Okay, the moon. This is according to Wikipedia. All right. The importance of Harran as the cultural center for Sin grew all over during the first millennia, especially under the influence of the ruler Nabonidus. And in the future talk about the moon, I'll come back onto that. We can see his empire here. Harran is right in the north of that, and it spreads right down here to and it also goes into Jordan and right down into Saudi Arabia. And we can find representations of Sin with the horizontal crescent moon right down as far as Al-Hayat here on a rock in Saudi Arabia. So that's a very interesting thing to look into. Now let's come back to Harran. And so here I have a table which gives the sun and moon angles at Harran for solstice and the major moon positions. So we see that Harran, the latitude here, which I showed 36.8698, that's the latitude. Now I've chosen the year 3033 BC. Now this is a long time before Abraham is supposedly said to have got there. The dating of the Bible is not very clear, but we're talking about 1000 BC maybe, not 3000 BC. But why have I chosen this date? Firstly, because obviously I'm showing a link between Harran and Göbekli Tepe, Harbetsuvan Tepesi, and Karahan Tepe. So I'm quite clearly showing that Harran was much, much older, that this central point on the plain of Harran was much, much older than is historically accepted for the moment. Okay, this comes out of the geometry. It's quite clear. And I'll be showing you another fact in a minute, which will absolutely confirm the whole thing. Okay, so Harran must have been much, much older than what is imagined. And I've taken a date here of 3000 BC. Why? Because at that particular date, the major moon angle was 36.869 degrees, which is exactly the same angle as the latitude. Now, this is the angle of a 3-4-5 triangle. This angle doesn't change very much. It changes very slightly over the thousands of years. But one can suppose that if it had been noticed that the major moon rose at Harran, we remember that Sin, the moon god, was very important. And if it had been noticed that the major moon rose at the plane of Harran on the exact angle of a 3-4-5 triangle when it was at its maximum position, and that Harran itself was at the latitude of the 3-4-5 triangle, then this would have made the place an extremely important place to be. And so one can understand that people would move over long distances to be there. Okay? So that's a very important point. The major moon at its maximum declination, so the most northerly rise would rise on the angle of a 3-4-5 triangle. I've shown how important this was in Karnak with the solstice angle. The solstice angle in Karnak was a 3-4-5 triangle. Okay? Now let's look at another of these Taz-Tepler sites. So there are a lot of them being discovered. And there's one that's been in the news ever such a lot, is the one at Sayburç here, Why has this been in the news a lot? Well, we'll have a look at this. So here we have Harran, and here we have Sayburç, up here to the northwest. Okay, so Karahan Tepe and Harbetsuvan Tepesi are northeast of Harran, and Sayburç is northwest. Okay, now here we have a satellite photo of an area where there have been excavations. There have been very important archaeological excavations going on in Sayburç for a few years now. And here you can see them on the aerial, on the satellite photos. This is a photo of that specific spot that I just showed you. You can see how they are digging around. And many very important things were found. So this is the spot I'm talking about, and the zone here has been excavated, and then further south also excavated. Here you can see more excavations slightly south of what I just showed you. And what are we discovering here? Well, look, here are these T-shaped pillars. So as they dig down under the ground, they're discovering a stone structure like Göbekli Tepe with T-shaped pillars inside it. And here, these archaeological diggers in progress, and all sorts of things are being brought out here. Here's a T-shaped pillar, perhaps with a hole in it. Here it is seen towards the side. So this is work in progress. Now this is a vertical photo taken above an area. So you see people, it's a town, so a lot of people are living here. And it's rather difficult for these people because there is talk about knocking their houses down because very important things are being found. It's quite tense what's going on in Sayburç. And you can see here how they're digging in people's gardens and discovering remains and digging holes here. And what they discovered underground in an underground chamber is really astounding. They discovered this kind of fresco carved on the rock here. This is an incredible sort of drawing. I mean, it's a representation on a long cliff face, a long rock face like this. And it's dated to the same time as Göbekli Tepe, probably about 9,500 BC, maybe even older, 10,000 BC. So very, very old. And we look at this in a little detail. So these are engravings from Göbekli Tepe, or sculptures on the T-shaped pillars of Göbekli Tepe. So we have a male lion here with its sort of vicious teeth. And on this pillar on the left here, we have this bull with its head turned to one side. We can see its two horns here. And of course, these two shapes here these two engravings are very, very similar to the ones found in this fresco at Sayburç. This bull here is virtually identical, with its legs pointing forward like that and bent in the back. It's virtually identical representation. Okay, and then there's a man here. Here he's holding his penis. And it's the same thing here at Karahan Tepe. This sculpture of a man was found in Karahan Tepe here. So these are very similar things, showing clearly that these must have been contemporaneous. Okay, so these are exactly the same drawings, so they must date from the same time. Göbekli Tepe has clearly been dated, with no doubt about it, because it was totally covered over. And so these are very, very important and ancient remains. Okay, now this figure here is between two lions. He's standing quite calmly between two ferocious lions. And I talked about this in my talk about Abydos, the temple at Abydos, where a a knife handle was found sculpted in ivory with a man, a Sumerian priest, standing between two lions in exactly the same way. Okay. This is a close-up. This is a rare photo and a close-up of his head. And we can see that his head is a very particular representation, very big ears here, and very protruding mouth and chin. Of course, it must be weathered, but it's definitely a strange representation. And we have the other figure here who, the one between the two lions is very calm. The other figure seems quite excited with his arms in the air. We can see that on his left hand, there are 8 fingers. Now, this could be an indication that he's moving his hand, sometimes to show a kind of movement. Things were multiplied like that. We find that in prehistoric cave paintings from a very long time ago. So it shows kind of agitation. And you see more fingers than the 5. He has 5 fingers on this hand. So, now what I'm going to say to you now is the most important part of the question of Sayburç, as far as I'm concerned, is its relationship with exactly the same point in the center of Harran, because what we're going to discover is that it is perfectly positioned according to a 3-4-5 triangle. So if we go exactly from the archaeological dig that's taking place in Sayburç to the center of the square at Harran, we have the perfect exact angle of a 3-4-5 triangle over a distance of 45,630 meters. Okay? That's quite an incredible fact. And this corresponds to the major moon angle. Now, this was true in 3300 BC, which this moon angle changes very slightly according to the Earth's tilt. So when the Earth's tilt changes, this angle changes slightly. Now, the Earth was tilted to its maximum around 8700 BC, around the time of Karahan Tepe, 9000 BC. We're talking about the sort of maximum Earth tilt. And so 3300 BC is 6,000 years. How many? 5,000 years after that position. So if we were to go 5,000 years before that, to say minus 13,000 or 13 or 14,000 BC, then we would have had exactly the same angle. Okay, so it's not possible. This could be much, much older. This moon relationship could, in fact, be much, much older and could date to 14,000 BC. Okay, because in 14,000 BC, we would have had also an exact 3-4-5 triangle angle on the major moon position. Well, that's something which is important to bear in mind. And then it would have come back around 3000 BC. The moon would have come back at its major position to that angle. Okay? So that's very important. I'd just like to show you the precision of this angle. We'll go to Google Earth. Let's go in here to Sayburç. We'll zoom right in. Okay. And I'll zoom into the exact spot where I showed you that there were the excavations. That's the square where they were doing the excavations that we saw in the photos. Okay, so I'm going to go from this exact spot where the excavations were taking place, and we're going to zoom right down. to the center of Harran. And if you follow my line, look, 126.86 degrees, 87 degrees, there you are. That's 90 plus 36.87 degrees. So that is the exact angle of a 3-4-5 triangle going from Sayburç down to Harran, okay? Right to the same spot from which our geometry was placed up to Harbetsuvan Tepesi and Karahan Tepe and up to Göbekli Tepe, etc. Okay, so that's just to show you the precision of this angle. This is not approximate, this is absolutely perfect. So that's a very important point. And of course, if we look at the distance, we have 45,630 meters. Now, in meters, that's a kind of canonical number. 2 times 3 cubed times 5 times 13 squared. This is the 5 side of a 3-4-5 triangle. So to get the unit, you get rid of the 5. So the unit will be 2 times 3 cubed times 13 squared, or 9,126 meters. So each square here has a side of 9,126 meters. Now, this will give us 3 units north-south, 27,378 meters, and 4 units east-west, 36,504 meters. Now, these two numbers are incredible. I mean, if this is coincidence, it's an incredible coincidence. If it's not a coincidence, then God knows what it is. Because 27.3 is the exact length in days of the moon's rotation. So we have 27.3 kilometers here. And the moon turns on its axis in 27.3 days, and the moon turns around the Earth in 27.3 days. Okay? But the east-west side is 36.5, 365, which is the number of days in a year. So this 3-4-5 triangle seems to incorporate a moon number, 273. 273 is also the number of days in the human gestation cycle. I've often spoken about that. So the relationship between 273 days, which is 9 months, and 365, which is 12 months, that's a 3 to 4 relationship. But here it's expressed in kilometers on the side of this 3-4-5 triangle between Harran and Sayburç. So thank you very much for listening to this talk. One can understand perhaps a little better why Abraham and his family went to so much effort to travel up to Harran. And thanks for listening, and don't forget to subscribe if you haven't already done so. And you can check out my Patreon channel, on which I put up new stuff first of all on Patreon, and then it comes out on YouTube channel. So if you want to get exclusive ad-free vision of my videos, then please sign in to the Patreon site. Okay, thank you. Bye-bye.